Good day, guys. I hope you are doing very well. This is Altin from Math and Science series. Today, we will be doing electricity from grade 10 to grade 12. Actually, before I continue the lesson, I'd like to thank those who subscribe to the channel. If you haven't subscribed, please make sure that you are part of the family or part of Math and Science series. We thank you guys for subscribing. We thank you guys for liking our videos. Actually, by doing that, you are making it to grow. So please do not forget to do it. If you haven't done it, please make sure that you subscribe the, the subscribe button and you hit the notification bell so that you can be notified when we upload new lessons. Okay, guys, so we do have our contact classes in Johannesburg, Vosloorus, where we are offering our classes from grade 10 to grade 12, physical sciences, mathematics, and life sciences. We have everyday classes for those grades from Monday to Friday afternoon. Our classes are commencing. Then we do have the program for those who are upgrading their physical sciences and mathematics results or who are upgrading. So their schedule is as follows. Every day from Monday to Friday and from 9 o'clock to 1 o'clock. We are actually from 9 to 9 o'clock, we are helping those who are upgrading their results. So since as I'm posting this video, as I'm uploading this video, with those that are upgrading, we are done with electricity, so we'll be doing something else on Monday. So please make sure that if you have a sibling or if you have a brother or a sister or a neighbor who might want or who wants the extra classes or who want a place to attend extra classes so that he can or she can write her or upgrade her or his results. Make sure that you check on our description below the contact. Actually, we have our contact on the description below so that you can WhatsApp or call us for more information. So today we'll be doing electricity from grade 10. Even if when you are in grade 10, make sure that you understand, make sure that you watch this video because it's very important for you to know how to interpret the diagram or the circuit diagram so that before you can use the formulas that are used in electricity to calculate whether resistance, voltage, or current. It is very important for you to know how to interpret what the circuit. So today's lesson is all about interpreting the diagrams or the circuit diagrams because many learners or most of the learners, what makes it difficult for them to solve electricity or electric circuit questions is that they do not know to interpret the diagram. So the key thing for you to understand or for you to know how to calculate whatever that they might ask you to calculate is for you to know what is for you to know how to interpret. So interpreting the diagram or interpreting the circuit diagram, that's the first that's the first port of call for you to do it to calculate. So we'll be doing basics or fundamentals of this topic because the easier or the more you understand the circuits and how to interpret them, that's when you can say that you know electric circuits. So I'm going to take you from electricity. When we talk about electricity, what comes to your mind is that we are talking about electric circuits. Yes, you are very, very, very correct. When we talk about electricity, we are talking about circuits or electric circuits. Now, there's a topic called electrostatic or electrostatics and electricity. Let me just give you a differentiation or let me just distinguish between the two, electricity and electrostatic. When we talk about the word electro from the word electrostatics, electro means electricity, then static, it talks about something that is not moving. Remember from Newton's second law in grade 11 or Newton's laws as a whole or as the concept. When we talk about a stationary object, we are talking about an object that is not moving, an object that doesn't have what motion or movement. So when we talk about the word static from the word electrostatic, we are talking about something that is not moving. So the word electro means electricity that is not moving or charges that is not moving. That's what we're talking about when we talk about electricity. I mean electrostatic. But when we talk about electricity, we are talking about the charges and where the actually we're talking about electricity where the charges are moving, the flow of charge. I don't know if you understand that. If you can go to your house, actually you don't have a house, if you can go to your parents' house, then you do what you find that the light bulbs are on, meaning that we are in the concept of electricity. But if you can go to your parents' house or where you are staying, then you find that the light bulbs are off. It means that we are now in electrostatic concept. Why? Because charges or current is not moving. I don't know if you understand that, but it's very, very important, guys, for you to understand that. Okay, now, as I said that when we talk about electricity, we are simply talking about what a circuit. So it's very important for you to know how or how does a circuit look like. So a circuit is something that looks like this. I will draw an easiest circuit here. Uh, so a circuit, something that looks like this. Uh, Positive terminal and the negative terminal. So this is how a circuit looks like. Or I can put an ammeter here. So this is how a circuit looks like. So we know that a circuit is made up of different components. For an example, a house, for me to build a house, I will never use bricks only. There are many components or there's apparatus that I must use for me to do what? To build the house. Specifications. They used to tell us that in technology, specifications, things that are needed. I don't know if I'm saying correct, but I think things that are needed for you to complete a particular task. So this is electricity. Now we have components that are making up this is the electricity. Then we have components that are making up what a diagram known as a circuit diagram. We have wires, we have switch, we have what is this? The resistor, we have an ammeter, we have a voltmeter. Then we have this is a cell. This is a cell because we have one positive terminal and one negative terminal. And you must be aware of these guys. This is a cell. The long terminal is known as a positive terminal, and the short one is known as a negative terminal. So this is an example or this is a sample of an electric circuit. Okay, we know that a circuit is made up of different components. We have this component, uh, we have this component. Okay, we're going to talk about the components that are forming an electric circuit. So this is a connecting wire or conducting wire. Then this one, it's a closed switch. When we come to switches, we can distinguish them into two switches, a closed switch and an open switch. This is an open switch. Open switch. Okay, so what you must know about a closed switch is when the electricity or when current is flowing, then the bulbs they do what they perform their function, giving us light. It means that the switch is closed. And when the switch is open, it means that current is not flowing, meaning there's no electricity, the house is dark. or we are in a dark city. That's very important for you to know. When the switch is closed, it means that there is electricity. When the switch is open, there's no electricity because current will flow. Okay, let me do this. Current will flow, and it does flow. It continues flowing, meaning that there's electricity. But when there's no electricity, it means that the switch is open, meaning that the current will flow and it will flow. Then it flows. When it gets to this side, it gets wasted or it leaks. I don't know if I use the correct way or term, but you understand it. Then it doesn't actually flow on that other part of the wire, meaning that there's no electricity. That's very important for you to know. Then we have something known as a what? As a bulb. As a bulb. Then we have something known as a cell. So we said that a cell has the long terminal, it's a positive terminal, and the short one is the negative terminal. So this is a cell, it's not a battery. Why? Because we have one positive terminal and one negative terminal. Then here, let me say we have something that looks like this. Positive terminal, negative terminal is known as a battery. So what's different between a cell and a battery? In a battery, we are having two positive terminals and two negative terminals, the smaller ones. Then what else? We have something known as a resistor. Or they can throw it like this. I'm not sure of the shape, but I try. Resistor. So the function of a resistor is to resist the flow of charge or is to resist current. Then we have this component known as a voltmeter. So grade 10s and grade 11s, you may be asked the function of a voltmeter. The function of a voltmeter is to measure voltage. And this is an ampere. This is an ammeter. So in ammeter, its function is to actually measure current. So guys, when we have these components, it means that we're having the specifications or the apparatus for us to make up an electric circuit. So this is very, very important for you to know. When we combine all of these things or some of them, we are having something known as a what? As an electric circuit. Okay, guys, so since in electricity we are talking about the circuits, or we're discussing about electric circuits or electric diagrams. So there is a law that governs the functioning or the operation of the circuits, which is Ohm's law, meaning that each and every circuit it is governed by Ohm's law or it follows Ohm's law. So if you're in grade 10, they won't ask you to state this law, but if you're in grade 11, they will, as well as in grade 12. But in grade 10, we'll only use its formula to do the calculations. So Ohm's law states that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So what does this mean? It means that the potential difference is what is the voltage, or they can use voltage. They can say the voltage across a conductor is directly proportional to the current in the conductor at constant temperature. We use this formula, V equals IR. So this formula is the formula of Ohm's law. V equals IR, where V is not the velocity but is the voltage or the potential difference measured in volts, or V. Then I is the current measured in amperes, which is A. Then R, the resistance measured in ohm. not ohm. Ohm. So it's very important that you know this stuff. It's very, very important. So what does this mean? It means that the potential difference across a conductor is directly proportional. When you talk about the proportionality of maybe variables, since they're saying that they are directly proportional, the potential difference or the voltage is directly proportional to the current, meaning that when voltage increases as well as the current increases. But when voltage increases again, it means that the resistance decreases. That's what the inversely proportional relationship. So it's very important, guys, that you know this. Now let's continue then. Okay, guys. Actually, here I want to be very, very slow, understood, and clear. Now we have two types of connections, or I can say three types. But let's talk about this one. We have a parallel connection as well as a series connection, meaning that a circuit or the resistors in a circuit can be connected in parallel or they can be connected in series or they can combine both the connections in one circuit. So in a parallel connection alone, current is not the same. Make sure that you focus here. This is the important thing that you must know before you can know how to do the calculations. Current is not the same, meaning current, in a parallel connection, we say that current or it divides the current. The parallel connection divides the current, meaning that for me to get the total current, okay, I total is not equal to the current that will flow in resistor 1 or equal to the current that will flow in resistor 2 or not equal to the current that will flow in resistor number 3. But for me to get the total current that's flowing throughout the circuit, I must add current that is flowing in the first or in the first resistor and add it with the current that flows in the second as well as the current that flows in the third current. Meaning that I must know that when the connection is parallel or when the resistors are connected in parallel, it means that the total current that is flowing throughout the circuit or from the power supply, it means that that current is not the same as the current that will flow or that will flow in resistor number 1, or it won't be the same as the current that will flow into resistor number 2, and as well as the current that will flow into resistor number 3. But for me to get the total current, I must add the current that will flow in resistor 1, resistor 2, and resistor 3 so that I can get what the current, the total current. Why? Because in a parallel connection, if we have 30 amperes that's flowing or that is discharged by the power supply, that 80 it will split since we are in a parallel connection. So the there's a magnitude of the current that we get into resistor number 1, resistor number 2, and resistor number 3. So it's not the same current. That's why we're saying that current is not the same. Meaning that for me to get the total current, I have to add that splitted current. Number 2, we're saying that voltage is the same. Voltage is the same throughout the circuit. So you must know these guys, that since voltage is the same, meaning that the voltage that is distributed by the power supply or the voltage across the terminals of the battery is equal to the voltage that we get in resistor number 1 and the same as voltage that we get in resistor number 2 and the same as the voltage that we get in resistor number 3. Meaning that the total voltage, it is the same voltage that got in resistor number 1, resistor number 2, and resistor number 3. That is why we're saying that voltage is the same. If we have maybe 20 volts that's measured across the terminals of the battery or the power supply, if it's 20, meaning that in resistor number 1 we'll have 20 volts, 20 volts, and 20 volts. Why? Because voltage is the same. Number 3, when it comes to resistance, they can say it's equivalent resistance or effective resistance, or as well as the total resistance. So this is very, very important. So the formula for calculating the resistance in a parallel connection, this is the formula 1 over Rp, or 1 over R parallel equals 1 over R1 plus 1 over R2 plus 1 over R3, depending on the number of resistors you are given. I don't know if you understand this. Then when we come to a series connection, here we say that current is not the same. Then here, actually it's the opposite. Current is the same. Current is the same, meaning that the I total equals to the current that will flow in resistor number 1 equals the current that will flow in resistor number 2 and equals the current that will flow in resistor number 3 if we are having 3 resistors. Then we're saying that voltage divide, it is actually the opposite of this. Voltage is not the same, or potential difference is not the same, meaning that the V that is actually that comes, or the voltage that is across the terminals of the battery is not the same as the V that we get in resistor number 1. It's not the same as the V that we get in resistor number 2. It's not the same as the V that we get in resistor number 3. But for me to get the V total, I have to do what? I must add the splitted voltages or the potential differences so that I can get the total voltage under a series connected resistors. I don't know if you understand this, guys. Then number 3 is the resistance. They can write equivalent resistance or effective resistance. Then this is the formula RS, not religious studies but series resistance, equals R1 plus R2 plus R3 plus, if you have maybe 20 resistors, you can add up to 20. So this is very important, guys. This is very, very important. I hope that I explained this. So you must know this table. I will remind you when we actually interpret our circuit diagram. So it's very, very important. Let's continue then. Let's continue. Okay. Suppose you are given this. I want to talk about the parallel connection. The parallel connection as well as the series connection, but only in calculating the effective resistance. Let me say this is connected in parallel, yet actually we haven't discussed or shown you guys how do we see if a circuit is connected in series or in parallel. But let's assume these ones are connected in parallel. Yes, they are connected in parallel. Let me say here it's R1, we have 1 ohm, and here it's R2, we have 2 ohms. And they want us to calculate the effective resistance. This is the formula that we use since we know that this one is connected in parallel. Since we're having 2 resistors, we write 1 over Rp equals 1 over R1 plus 1 over R2. So this is very important, guys. Make sure that you follow. So I'm doing this. I know that we haven't discussed on how to interpret if a circuit is connected in series or in parallel. So I'm just using this one because many learners are making this mistake when it comes to calculating the effective resistance of a parallel connection. You write 1 over Rp equals 1 over R1, which is 1 ohm, plus 1 over R2, which is 2 ohms. Then 1 over Rp equals, since I don't have a calculator, punch it in your calculator. Then it will be 2 plus 1 over 2, which is 3 over 2. So the calculator will give you this thing. Now it will be 1 over P equals 3 over 2. Then what you must do, you must reciprocate this fraction, meaning that the 2 will be a numerator and actually the 2 will be a numerator. Now the calculator will give you 3 over 2. But after getting this answer, make sure that you reciprocate them. 2 becomes a numerator and 3 becomes a denominator. Then you write it not in decimal form. Then you write actually there a SI unit for resistance, which is ohms. But if we are given, let me say this is connected in series. Let me say this is connected in series. We have 2 ohms, maybe we have 6 ohms. Then they want us to calculate the effective resistance. Rs R1 plus R2, why? Because we are having 2 resistors. R1 is 2 plus 6, which is 8 ohms. So this is how we are actually calculating the equivalent resistors. Equivalent resistance of the different or the 2 connections. But I wanted to emphasize on this one because it's very important. Many learners are making a mistake here. After getting 3 over 2, make sure that you reciprocate your answers. Then you actually leave them in decimal form. The purpose of this lesson is to show you how to interpret the diagrams in differentiating or distinguishing if they are connected in series or in parallel. Okay, now we know that this is a what? This is a cell. We have a positive terminal as well as a negative terminal, and we have a current. You must write this down. Conventional current, not convectional. Conventional current is the current flowing from the positive terminal to a negative terminal. You must know that grade 10 and grade 11, they can ask you to actually define it. Conventional current, current flowing from a positive terminal to a negative terminal. Then, since this electric circuit is like this or is drawn as it is drawn on your screen, the current that will flow from the power supply is the total current, meaning that for me to actually interpret this, we talk a lot about current, how current behaves when it gets in resistor number 1, resistor number 2, and resistor number 3, and how as a voltage behaves when it gets in resistor number 2, resistor number 1, and resistor number 3. So the current from the power supply, when it moves or when it flows as a total current. So it flows, or it is flowing as a total current. It is flowing as a total current. It is flowing as a total current. Then it goes down as a total current. Then it gets in resistor number 1. So since it got in resistor number 1, we know that the very same total current that was discharged by the power supply, it got in the resistor number 1 as a total current, meaning that for now alone, resistor number 1 is connected in series because we're having the same current as the as the I total. I don't know if you understand that. Now the very same total current is flowing again out of resistor number 1, approaching resistor number 2. Then it gets in resistor number 2, meaning that in R1 and R2, the current that was flowing in resistor number 1, it is the total current that was discharged by a power supply. Then it gets in resistor number 2, meaning that resistor number 1 and resistor number 2 for now, they are connected in what? In series. Why? Because we're having the same current that is flowing inside the resistor. Now, the very same total current goes out from resistor number 1, going or flowing as it is flowing, then it gets in resistor number 3. Meaning that in resistor number 1, resistor number 2, and resistor number 3, we have the total current that is flowing in these resistors. Then it comes out going to the negative terminal, conventional current, right? Meaning that R1, R2, and R3, they are connected in what? In series. Why? Because there's the same current that was flowing in resistor number 1, resistor number 2, and resistor number 3. Because you cannot calculate the effective resistance if you do not know what the type of a connection we are having in our circuit. So this is the series connection. Since we know that it's a series connection, we know that if we can be asked to calculate maybe V total, since we know that V total in a series connection, you can look on that table that I gave you guys. V total, we calculate V total as V at resistor number 1 plus V at resistor number 2 plus V at resistor number 3. Why? Because when a circuit is connected in series, we know that voltage is not the same. Therefore, for me to get the voltage or the total voltage, I must sum or I must add the splitted voltages that are actually distributed to the resistors. Then what about the equivalent resistance? I know that this is connected in series. Therefore, R1 plus R2 plus R3. This is very, very important. This is what you do before answering questions. You do have to analyze the diagram. Then after analyzing the diagram, you get your data, the formulas that you're going to use as I'm doing here. Now, what about the I total? We know that I total equals I at resistor number 1 or I at resistor number 2 or I at resistor number 3, meaning that I can calculate the I total only by using R1. Let me say I'm given the value of R here and I'm given the value of V. I can use this resistor to calculate what? To calculate the total current, because the current that is flowing in resistor number 2 is the total current. So this is the information, or this is what you must know before doing what? Before running two calculations. It's very important that you distinguish the type of connection that is present in that particular circuit. So it's very important, guys, that you know these things. Very, very important. If you didn't understand this first one, make sure that you actually pause the video and start it afresh and understand that table, because we are controlled by that table. Okay, let me draw the second one. Let me say we have this circuit. We have R1 here, and here we are having R2. So you must actually interpret that circuit diagram, because you cannot calculate whatever if you don't know the connection or the type of connection. So from a positive terminal to a negative terminal, this is what the current flowing. All the time, use this method. The total current is flowing from the terminals of the battery or from the power supply, and it gets into resistor number 1. So the very same total current that was discharged by what? By the power supply, it got in resistor number 1, meaning that resistor number 1 is connected in series, because we're having the total current that's flowing into resistor number 1, and it got out from resistor number 1, then it went to, or it's approaching resistor number 2. And the very same total current got in resistor number 2, meaning that resistor number 1 and resistor number 2, they are connected in what? They are connected in series. Why? Because the total current was the current that was actually distributed to these resistors. So they are connected in what? In series. What we know about resistors that are connected in series, we know that V is the same. Not V is the same, but current is the same, meaning that the I total equals to the I that got in resistor number 1, as you saw, and I that got in resistor number 2. I don't know if you understand that. By me having this information, I can actually calculate the I total using using R2 only. If I have V and R here, I can calculate what? The I total of the circuit. Since I know that the total current that will, the current that will get in resistor number 2 or resistor number 1, it is the total what? It is the total current. What about the V? For me to calculate V total, we are under series connection. It will be V at resistor number 1 plus V at resistor number 2. Because if we are given, let me say we are given 30 volts. It's not that we'll have 30 here and we'll also have 30 here. We said that voltage is not the same. Therefore, for us to calculate the voltage in a series connection circuit or resistors, we have to add the splitted voltage. And what about equivalent resistance? It's R1 plus R2. So these guys are the fundamentals. So this is how you interpret the diagram. So this is very important. Make sure that you do not forget to like, share, and comment after watching this video. Okay, let me say we have this kind of a circuit. My goodness. This is what you must know, people. Then let me say here you have another resistor. This is R1, this is R2, and that's R3. They want us to actually check if this is connected in series or in parallel. Okay, so from a positive terminal, you know the trend now. The current will flow. This is the total current. But when it gets into this point, this is where the parallel connection is introduced, meaning that we will find a parallel connected resistors. So the current will split the other amount or the other magnitude of the current will get in resistor number 3, then this one will continue. Remember, it's not the total because it got disturbed on that point. Then even here, it is getting disturbed, the splitted one. So it will come this side and it will come that side, meaning that these three resistors are connected in parallel because the resistor that got in resistor number 1, the current that got in resistor number 1, resistor number 2, and resistor number 3 is not actually the same current, or it's not the total current. It's not the total current. And this one comes and flows in, then it gets out and waits here for its twin. I don't know if you understand this. And it comes out and it's actually they meet at that point. Remember, this is the splitted one from that point. Then after they met, they wait for this one. Then it comes, then they meet. Now we have what the total current from positive terminal to the negative terminal. But pay attention, the I in the resistor number 1 and resistor number 2, or as well as in resistor number 3, it can be the same in a parallel connection only if the magnitude of the resistance, the magnitude of the resistors or the magnitude of the resistance is the same. I don't know if you understand it. But this one here is connected in what? In parallel. We know that when it's connected in parallel, V total equals V at resistor number 1 equaling V at resistor number 2 and V at resistor number 3. Let me say we have, let me say it's 20, let me say we have 20 volts here. Since we are having 20 volts, it means that the voltage that is actually distributed across the resistors in a circuit. Here we are having 20 volts, and here we are having 20 volts, and here we are also having 20 volts. Since we said that in that table, in a parallel connection, the voltage is the same, or the voltage that is distributed, or the voltage across the terminals of the battery is the same. Then what about equivalent resistance? We use this formula: 1 over Rp plus 1 over R1 plus 1 over R2 plus 1 over R3. Why? Because it is connected in what? In parallel. Then what about the I total? The I that we get in resistor number 1, resistor number 2, resistor number 3 is not the same as we were interpreting there. Meaning that for me to get the I total, I must add the I that got in resistor number 1 with the I that got in resistor number 2 and the I that got in resistor number 3. So this is very, very important, guys, that you know this. It's very, very important. Okay, here's the third one. From a positive terminal to a negative terminal, the total current flows, or the current flows. Check, it doesn't go to that side. This is the voltmeter. It doesn't go to that side. So it passes as if there's nothing there. So this is where the parallel connection is introduced, meaning that the current will split, or current will be divided, but not in equal magnitudes. So we know that the current that will flow into resistor number 1 is not the same as the current that will flow in resistor number 2, only if they have the same magnitudes of the resistance. If we have two, then if we have two, meaning that the current will be divided into two equal parts, meaning that we'll have the current that will get in here is the same that as the current that will get in resistor number three. That's very important for you to know. But let's assume as if this current, these resistors, they have different resistances. Now, as the is flowing, it means that resistor number one, resistor number three, for now they are connected in what? In parallel, because we have the current that is flowing to resistor number three is not the same as the current that is flowing to resistor number one. Then, as you can see, that the current that is flowing out of resistor number one, it is the same current, the splitted current that will get into resistor number three, meaning that inside the parallel connection, we got what? We got the same, or the resistors that are connected in what? Are connected in series inside what? The parallel connection. Meaning that R3 is not in parallel with resistor number one only, but it is in parallel with both the resistors, because the current that gets in resistor number one is the same current that gets into resistor number three, the splitted one. I don't know if you understand that. Now, when it comes out of resistor number three, number two, then this one waits here for the current that is flowing to resistor number three, and it went out, then they meet here. Then from positive terminal to negative terminal, that's conventional current. So this current, these circuits, we found that there's a parallel connection that is existing in these circuits. Oh my goodness, English. Okay, now inside the parallel connection, we got that these two are connected in what? Are connected in series, but inside the parallel connection. So for me to continue with whatever that I can do, I have to cancel these two. How do I cancel them? I destroy this one by doing what? By adding the two resistors that are connected in what? In series. Therefore, for me to have a total, for me to actually interpret this so that I can have formulas to use, V total, since it's connected in parallel, for me to get V total, I can use this formula since it will be V at 3. So V at resistor number 3 is the total current that will get in there. But for me to get V total in this one, since they are connected in series inside a parallel connection, this is what I will do. It will be V total equals V at resistor number 1 plus V at resistor number 2. I don't know if you understand this. Let me say I have another resistor here. Okay, which is resistor number 4. Then, for me to do the calculations, I must actually destroy these two, the series connection inside what? The parallel connection. How do I cancel them? How do I destroy them? I destroy them by doing what? By actually adding these two resistors. Okay, I don't know if you guys understand this, but it's very important that you get this. We're saying that here the parallel connection got introduced, right? Then the current that will flow in resistor number 1 is not the same as the current that will flow in resistor number 3, meaning that they are both connected in what? In parallel now, or for now. Now, the very same current, the splitted current that got in resistor number 1, it is the current that actually got in resistor number 2, meaning that inside the parallel connection, we are having a series connected resistors. Therefore, if we have a circuit that's connected in parallel, then inside of the parallel connection, we have a series connection of resistors that are connected in series. We have to destroy them. How do we destroy them? We destroy them by doing what? By adding them. I don't know if you understand that. So as I explained that the splitted current, actually they meet here with the current that is coming this side and that current that's coming from that side. So they meet here, this is the total current, meaning that in resistor number 4, we will have the total current flowing in resistor number 4, meaning that resistor number 4 is connected in series. I don't know if you understand that. It's connected in what? In series. Okay, let me just erase this thing. We'll talk about it later after this. So this one, the current that gets in here is the total current, right? Why? Because the splitted currents, they met at this point, meaning that at this point, this is where the series connection maybe gets introduced only if there are other resistors in place. So it's resistor number 4, meaning that in resistor number 4, we'll get what? The total current that will flow into it. I don't know if you understand that. That for me to calculate V total, so we can see that this is the combination of both the connections. We have what? The parallel connection as well as the series connection. But here inside what the parallel connection, we are having a series connected resistors, meaning that I have to destroy them. How do I destroy them? You add the resistance that will be given in resistor number 1 and the resistance that will be given in resistor number 2. By that, you actually destroy them. So the V total, it will be V total. Okay, check this one and this one. They are connected in series, but inside what? The parallel connection. They are not in series with what? With R4. I don't know if you understand that. They are not in series with R4 because for me to cancel them, for me to destroy them, I have to do what? I have to add them. Meaning that when I cancel them, we'll have two resistors. Well, we'll have something that looks like this. We'll have something that like this, meaning that R1 being summed with R2, they are both actually, these are what are connected in parallel. Meaning that for us to get the V total, we use this formula V at P plus V at S, meaning that parallel voltage plus series voltage. I don't know if you understand it, because if we have 20 volts here, that 20 volts is not going to be distributed to those resistors that are only connected in parallel, but also to the resistor that is connected in series, meaning that it will split. It will split. I don't know if you guys understand that. Then for I total, I can use two ways. For I total, I can use a V T. I mean I total. I total equals I at resistor number 1 plus I at resistor number 3. Because this we actually sum them. When you say we have 3 and we have 4, it will be 7 plus the resistor that will be having or that will be given in resistor number 3. So this is the formula for us to find out the total current. Or we can use this formula IT equals I4. I don't know if you guys understand this. Or let me say we have this one here. We haven't removed it yet. We have our resistor here as resistor number 2. We can also use this formula if you like. You can use this formula for you to calculate the I total. You can write I total equals I at, it's one and the same thing. It's one and the same thing. It's one and the same thing because the I that we get in here is the same as the I that we get in resistor number 2. So these guys, is very, very important for you to know. Make sure that you understand it. Make sure that you understand these guys. That when you are given a series or a parallel connection, then inside the parallel connection you find that you have you have a series connection inside a parallel connection. What you must do, you must add those that are connected in series. It's very, very important. It's very important. Then let me say we have, okay, let me say we have, I want to show you these because these are actually problems. They are found in your past papers of exams. You say that this is R2, this is R1. Okay, let me say here we have 1 ohm, and here we have 2 ohms, here we have 3 ohms, and here we have maybe 5 ohms. Then the V that is measured across the 3 ohm resistor, since we are having the total one there, the same that here we have maybe 6 volts. So this voltage that is measured across the 3 ohm the 2 ohm resistor or R3 is what is a parallel one, meaning that since we know that these they are connected in what in parallel, it means that they share the same voltage. I don't know if you understand that. We said that in a parallel connection, we know that the voltage is the same. That's what we said, right? That's what we said. Then we know that inside the parallel connection, we'll do what? We'll add, inside the parallel connection, if we have a series connected resistor, we'll add those resistors. Make sure that you follow, guys. This is very, very important. It's very important. Okay, so we know that R1, R2, and R3 they are connected in what? In parallel. But we know that we'll add this one and that one, meaning that we'll have 1 plus 3 here, meaning that here it's no longer a 1 ohm, but it's what? It's 4 ohms, meaning that the 4 ohm resistor and the 2 ohm resistor they share the same voltage. I don't know if you understand that, but that's very important for you to understand, guys. So I've cancelled it or I've destroyed it. I've destroyed the R2 resistor. So let me say you are asked to calculate Vx 5 ohm resistor. This is the formula that we're going to use. V total equals P plus Vs, which is V parallel and V series. So V total, we have the V total, right? Which is 20 equals Vp. Vp is 6 plus Vs is we don't know Vs, that's why we are calculating. So it will be 16, no, it will be 40. V equals V at S. So this is what the resistors. I mean, this is the voltage that is measured in resistor number 4. So guys, this is very, very important. This is very important, guys. Okay, suppose you are given this circuit and you want to calculate the total current as well as the total resistance. Okay, the first thing that you must do, check if it's connected in parallel or in series, plus, minus. Now, positive terminal, from positive terminal to negative terminal, the total current flows, right? Current is flowing, conventional current. Then this is an ammeter, it measures the current. This is the total current flowing. Then at this point, this is where parallel connection is introduced, right? Meaning that other current will go to resistor number 6, and this one will come to resistor number 4 and resistor number 8. And you can see that the current that gets in resistor number 4, it is the very same current, the splitted current that will get in resistor, 4 ohm resistor to 8 ohm resistor. I don't know if you understand that, guys. Meaning that the current that flowed in resistor number, or the current that is flowing in resistor number 4 and resistor which is having the resistance of 4 ohms and the resistor which is having the resistance of 8 ohms, they are sharing the same current. Why? Because they are connected in what? In series, inside the parallel connection. But we know that we must do what? We must destroy these two, or we must destroy a series connection inside the parallel connection, meaning that we have to add them. We will have 12. Just add them. 4 plus 8, we're going to have 12. So when we have 12, it means that we actually destroy this one. Now we have 12. We destroy the series connection. I don't know if you understand that. Since we destroy this, or we destroy the series connection, we are having something that looks like this. We're having something that looks like this, but now it's 12 ohms. So this is a what? It's a series that is connected in parallel. I don't know if you understand that. So for us to calculate, so we'll have something that will look like this. Okay, let me just go back to what we were having. It was 8 ohms here, and here it was 4 ohms. Now, for me to calculate the R total, okay. Now, the splitted current, now it moves out from resistor number 8, then it waits here for the current that flowed in resistor number 6, then they meet here. This is the total current, meaning that it gets out. I don't know if you understand that. Now the current that we get or that will flow in resistor number 3 is the total current, meaning that this is what this is it's a series connection, or it's a series connected resistor, meaning that the circuit here is the combination of both the connections. I don't know if you guys understand that. So even if here I can remove it and actually write 12, because that's what I said, right? This is 12 ohms. Now for me to calculate R total, this is the formula that we'll use. R total, it will be R parallel plus R series. Then R parallel, it's what? Okay, before using that formula, I will write 1 over Rp equals 1 over R1 plus 1 over R2, which is 1 over 6 plus 1 over 12. Then you punch that in your calculator. 1 over 6 plus 1 over 12. It will be 1 over 4. The answer, it will be 1 over 4. Then we know that you reciprocate it, you will have your answer as 4 ohms, right? This is Rp. But what about R series? R series is 3 ohms. Then they want us to calculate what? The R total. For us to calculate the R total, it will be R total equals Rp plus Rs, because we're having the combination, right? Meaning that Rp is 4 plus 3, which is 7 ohms. That's our R total, or the current, the R that is actually opposing the current. Therefore, when they want us to calculate, let me say they want us to calculate the current that is flowing. We know that the R total is what? It's 6. I mean, it's 7 volts, and not R total, it's not 7 volts, it's 7 ohms. So, because we have V total here, which is 14, this is V total. Now, they want us to calculate they want us to calculate I total. V equals IR. We know that our V is 14. For I, we don't have it. What about R7? 4 times 7, we have 14 equals 7I. Then we divide by 7, we divide by 7, we have 2 amperes. That's equal to A. So you will never know these guys if you do not know how to interpret the diagram. So it's very, very important for you to know how to interpret the diagram. If you are having a parallel connection, then inside the parallel connection, you are having a series connection. You destroy that series connection by adding those two resistances. I don't know if you guys are following. Then let me say maybe we are out of this. Let me say here we have 3 volts, and here we have 3 volts. Then here we have, let me say, is 16 volts. Then they want us to calculate V total. Now for us to calculate V total, it's VT equals Vp plus Vs, right? Now for me to continue here, for us to calculate the V total, Vp is 3, not 3 plus 3, because they're connected in parallel. No, it doesn't work like that. You take one V, you take one voltage, right? Because the voltage that is actually distributed between these between these two resistors, they actually share the same voltage. So it will be 3 plus, that's 16, which is 19 volts. So you must make sure that you understand this, because here we said in that table, if you can go back to it, we said that the voltage that is measured in a parallel connection is the same. So they can actually write it like this just to confuse you, not knowing that maths and science has taught you this. Okay, guys. So it's very important that you know how to interpret the diagrams.